It turns out that for a real electron, this is completely the wrong story. This is not the way it works. Something else happens, which illustrates the weirdness of the quantum world. It is not as we expected. It does not behave the way it should if it follows the laws of classical physics. First of all, no matter which way you prepare the electron, then you turn on the magnetic field, and one of two things happens. Only two things could happen. One is that it emits no photon, no electromagnetic radiation. The other is that it emits one photon of electromagnetic radiation of a very particular frequency that corresponds to the energy of jumping from down to up. It is almost as if the electron had only two possible configurations. There are only two states of an electron, either it is pointing up or it is pointing down. That is one of the puzzles of quantum mechanics. Of course, there is a whole lot of mathematics and quantum mechanics dealing with that. Yet, here we want to examine the effect of the angle of intersection of the wave with its axis. Let's consider the electron as a fluctuating wave. As mentioned above, it is expected that the angle of intersection of a wave with its axis is the main factor determining the effect of the wave on the environment, field, or system. Following this line of thought, electrons and other fundamental particles should not be changing amplitudes and should not be changing the angle of intersection of a wave with its axis. In other words, since they are fundamental, the update of their wave function should not result in changing the angle of the intersection of a wave with its axis. This is, again, of course, just an analogy aiming at examining the effect of the angle of intersection of a wave with its axis, and whether this idea could be applied to subatomic objects with quantum mechanical behavior, and it will require further scientific research and validation.